Hey, how's it going? Leetcode 1361. Validate binary tree nodes. You have n binary tree nodes numbered 0 to n-1, where node I has two children, left child I and right child I. Return true if and only if all the given nodes form exactly one valid binary tree. If node I has no left child, then left child I will equal -1, similarly for the right child. Note that the nodes have no values, and we only use the node numbers in this problem. Okay. So left child, 0, position 0 is 1 and 2. So that's this, and it points to 1 and 2. Okay, that makes sense. Well, we need to find out that there's no cycles, that everything is referenced once except the root, and actually, I think that'll do it. As long as there's not more than one head, there can't be two binary trees. So let's do it. Root equals -1. Now we're going to say ls equals set of left child, rs equals set of right child. And then we're going to say for I in range n, if I not in ls and I not in rs. If I not in ls and I not in rs, then what? Then if root equals -1, then root equals I. Otherwise, return false, because that would mean that we have two roots. Now, everything can be at most one child. So, you know what? The child of one node. Let's do it this way instead. Wait, I don't need that again. I can do it right here. So if ls of I plus rs of I is greater than 1, then return false, because you can't have two things pointing to the same object. Now all we got to do is just iterate the tree and make sure that everything gets touched once. So unvisited equals set of range of n. Now we should have the root here. We want to do it recursively. You know what? Sure, let's do it recursively. That's fine. R of I. Now we're going to say if I equals -1, then return. Well, let's not do that. If I doesn't equal -1, if I in unvisited, then it's valid. Then we're going to say unvisited dot remove I. Otherwise, we've seen something twice, so return false. Now, if I in unvisited, then remove I, and then we have to visit the two children. So it's just going to be left child of I and right child of I. Oh, if there's no root, if root equals -1, then return false. Then return true. Actually, do that down here. And we will return r of root. No, we're not going to do that. If not r of root, then return false. That is true. Now we're going to return length of unvisited equals 0, because we have to have visited every node. Woohoo! It's always fun when it works on the first try. Hopefully I don't eat my words. All right.